Hello again. So we talked about probability distributions for discrete random variables, and we talked about how to compute the mean and the standard deviation of the variance of a discrete random variable. And I just want to give one more interpretation of what it means, what about the mean, and it's a little more maybe in practical terms. So the mean of a random variable x is also called the expected value of x. Okay, it's like I said, it's the theoretical average. It's what you would expect x to be on average after thousands of trials. Okay, if you were to run this experiment thousands of times, this is what x would be on average. Now, to give you an example of how this works, I want to just share a little story. So a long time ago, I went to Las Vegas, and I went to my first casino there, and the first game I played was the roulette wheel. And it was really, I liked it because it was so simple. And how you do is you bet on there are many ways you can play this game, but basically the roulette wheel has 38 numbers. It's actually numbered 1 through 36, and then they have a 0 and a double 0. And then you bet on one of those 38 numbers. So we will just say, to make things simple, we'll just say you bet on a number between 1 and 38. And then if the ball lands on your number, you win $35. Otherwise, you lose $1. Okay, or whatever the minimum bet is. The point is the payout is 35 to 1. Okay, if you win. So I think what happens, we can see that the probability of winning, picking the right number, the ball will fall on the number that we picked 1 out of 38 times. Okay, and then 37 out of 38 times we will lose, right? So the way we want to think about it is we ultimately want to know what is the amount we're winning. Okay, so let's say if x is if we let x be our total winnings. In terms of dollars, okay. Now we can see that it's either going to be 35 or -1, right? Those are actually this is our we're allowing x to be negative, so we can see that x is either going to be 35 or -1, because those are our only options, right? We don't have to write all 38 options down, right? We know that 37 out of 38 times we're going to lose $1, and the 1 out of 38 times we're going to win $35. So our probability distribution would look like this. So here's -1, here's 35, and the probability would be of losing would be 37 out of 38, and then the probability of winning would be 1 out of 38. So our mean would be -1 times 37 over 38 plus 35 over 37 times 37 over 38. Okay. Sorry again, I missed that up. This should be a 1. Sorry. 1 out of 38. Okay. So then this is, well, what will this be? This will be negative 37 over 38 plus 35 over 38. And you know that we have a common denominator. -37 plus 35 is -2 over 38. And you'll notice that this is a negative value. So on average, we're losing -2/38 of a dollar every time we play. And in fact, 2 divided by 38 so this would be -0.0526. So that means when we play this game, regardless of whether we win or lose, theoretically, we're losing a little more than a nickel. Or to be more precisely, we're losing a little more than a nickel for every dollar we bet. Okay. And this is this is how we compute the house edge. Okay, and that's how the house edge of this bet is. We would say that's 5.26%. Okay, So, like I said, that tells you how much you can expect to lose in this. And you'll see that this is actually, well, even though this is a wonderfully simple game, and it seems like 35, okay, hey, betting $1 to win 35, it seems like such a great idea until you can see this calculation, right? And this is actually the house edge. This is one of the highest games with the highest house edge. If you play other games like craps or blackjack, the house edge is much smaller. It's like around between 1 and 2%. For blackjack, it's actually about a 0.5%, right? Although the calculation for that is much, much more difficult for that. But this is why the casino, when you've heard the expression, the house always wins, and that's because the people who run the casino, they are well aware of these probabilities and these how to compute the house edge. There is no way that they would ever put a game out there where the player has an edge. Okay, and that's why the only people who get rich from these games are the casino people who run the casino. Okay, so keep that in mind. All right, and that is it for today, and I will see you next time.